Hey there everyone, here's a quick tech talk on the Model PL4000 portable lathe. This is the largest of the three portable lathes that Climax makes. This is an all pneumatic powered machine, so the rotation and the feed is run off of the air system. Air system is supplied through the pneumatic conditioning unit and this set of rigid pipes that plug into the back of the rotary union. And from there, it sticks out the back end in clearance of the turning arm. So as that's rotating, that rigid arm set comes out the back of the motor and gives clearance so that the tool head and the tool arm doesn't grab the airline. Here's some of the key points to be looking for on the lathe. As with most of the tools that we have, there's going to be a traveling tool head. We'll need to check the doveways on that, make sure that those are good. Clean. Make sure the gib screws are in place. Make sure that the full length of the gibs, top and bottom, are in good working order. As with the many machines with the doveway on a portable machine, they're going to get loaded up with chips, and it's pretty easy to get some galling and some scarring in the doveways. So you can file those down, get them cleaned up, and make the tool working again. Something else to check every time is the amount of backlash or the condition of the lead nut on the tool head. Best way to do that is to just lock down one of the gib screws, and then coming to the back of the feed arm, just try and move the hand crank here a little bit. This has got very little movement. We're talking maybe an eighth of a rotation or so. That's actually okay. If you get to the point where you've got half, a third rotation, that's an indicator that the brass nut is wearing out and needs to be replaced. This is the only lathe in our fleet of tools that has a fully adjustable turning arm. This arm can be moved in towards the body and away so that you can work on larger or smaller diameters of shafts. This tool is also capable of tipping at an angle so that if need be, the operator can cut a taper on the workpiece. Most people need this straight, though. So it's important that when you're servicing the machine, you see these little cup marks on the back of the slide arm. That is from these locking screws. These are cup point screws, and they're intended to dig in so that the arm doesn't fly off while it's rotating. What happens, however, those cup point screws, not only do they leave a groove or a little ring, they'll leave a high point. You got to get these covers off and lay a file or a stone on top of all four of these surfaces to get those high points off. The reason for that is when the operator has a dial indicator and they're trying to level the turning arm into position, if those screws drop into one of those divots, it's gonna affect the arm. It's going to want to self-center itself. It'll want to find the path of least resistance. So the cup point screw here is going to find one of those grooves, and it's going to make it difficult to set up and align the bar. So again, get these covers off, file down these plates smooth, and we're good to go. One of the things we get called on the most from the field is customers getting erratic or non-working feed. 9 times out of 10, it's a simple fix of repositioning this cylinder body. As the air comes into the machine, it's rotating around this 4-point cam system through this air actuator body, following out to the piston. As you can see, there's a bronze bushing here and a steel piston that cycles in and out 4 times per revolution. Because of the size and the weight of the machine, a lot of folks use chain falls, straps, and other rigging devices. And because the arm is sort of sticking out there in space, a lot of times this will get bumped into the crate against the workpiece, or a chain fall might wrap around it. And moving this even just a little bit can put this piston in a bind. So the quick fix to that is just loosen these 4 screws. You don't have to take them out. You can leave them in place, but they need to be loose enough that you can move the piston body freely on the gearbox. You do that, Ideally, if you can cycle it, you can put a little bit of air to it and make this piston actuate in and out. It'll self-center. It'll sort of right itself to its freest position. Once you've done that, you can lock the screws down. Just be careful not to tighten them down too much. That saw split on the side is the exhaust for the piston. The drive on the machine is pretty robust. It's got two very large tapered roller bearings in the housing here, along with a large diameter brass worm gear driven by a steel worm. So while this is really heavy duty, the weak point is going to be on the Ingersoll air motor. Inside his planetary housing, there's going to be some very small gears and pins, along with small bearings and the phenolic vanes. More often than not, the only maintenance point on these motors is the vanes. You take the motor off and you replace those 5 vanes and they're going again. But from time to time, because of the hammering going over a welded surface, these planetary housings, those can fail eventually too. But for the most part, the machine is really strong and robust, and because of that worm drive system, it's pretty efficient, so even the motor lasts a long time. We've got the machine mounted up onto our assembly test fixture here. In most cases, out in your workshop, you're going to have this sitting on top of the crate or on the floor or a workbench. So a good way to test the air motor is to grab a hold of the mounting hub and just try and rotate it back and forth. Here on the workbench or test stand, I'm going to rotate it with the turning bar. What we're going to listen for and watch for is how much movement I have in the bar before we can tell the air motor is starting to turn. So we're checking, what we're doing is we're checking the gap or the play in the worm set here, and we're checking the condition of the air motor. So I can pull on the motor or the arm a little bit. You can see I have very little movement before the worm drive engages the air motor. If you pull it a little bit more, you can hear the motor turn. You need to listen to see how smooth it is. It should sound very consistent. You should hear the vanes turning. You should not feel any bearings clunking or gears clashing.